Hello students, this is Mr. Hart, and in this lesson we want to talk about observation and inference. Now this is going to be a very important skill that we'll need in earth science and in science in general. In your day-to-day life you don't really need to separate these two, but there's a lot of things in science that we can't observe directly, and so we need to be able to separate our observations from our inferences. So to start, let's just make sure we understand what those two words mean. So when we're talking about an observation, we're talking about some fact that we can acquire directly through sensory or some kind of measurement. So something we see or something we hear, etc. But when we're talking about an inference, it's some kind of conclusion we reach based on that observation. So for example, let's say you go to your friend's house and you notice that their car is missing from the driveway. Okay, you see that there's no car there. You might observe that there's no car there and thus infer that your friend isn't home. And so the observation is there's no car, and your reasoning and your inference is that that friend may not be home. You could make additional observations and go knock on the door, and if no one answers, that's probably another good inference, right? Or reason to believe that they're not home. And so as you make more and more observations, you can make better and better inferences. Now the reason we want to separate these, and especially in earth science, is there's a lot of things we, again, can't observe. We'll look a lot into the past, and we'll look a lot into the outer parts of space, etc. So we have a lot of good evidence for things out there, but we can't observe things directly, right? Especially things in the past. We can't travel back in time. And so we have to infer based on the observations we do have, but those inferences are still just very educated guesses, if you will, right? We still are concluding something based on them, and we can't know for sure until we get better measurements. Okay, let's practice a little bit more with observation versus inference. Okay, so for example, look at this picture. There's a lot of things you can observe directly. Okay, there's a balloon-like object in the sky. That's blue. Okay, there are people down here on the ground. Okay, and some cars. There's green grass. The sky is nice and clear. Those things we can observe directly without making any prediction or guesses. Okay, but there's some things we can infer that we probably do without even thinking about it. That balloon is probably a hot air balloon. You know this from past experience that to get a balloon that big to lift people up, it probably has to be filled with hot air. Okay, you probably can infer that these people down here are there to watch the hot air balloon. Maybe they helped set it up. This is probably earlier in the morning based on, you can kind of see the sunlight a little bit on the mountains, and you can just again from prior experience know that hot air balloons generally fly during the morning because it's better weather for them. You can also guess kind of the time of year because there's snow on the mountains but not on the ground. So it's probably spring, maybe early summer. And so again, those are all things we can determine and make really good guesses on based on those observations. And in the rest of your life, that probably doesn't matter, but in science, it's really important to separate those two. Okay? Now in class, we did an activity. We did two activities. We did a black bottle experiment, which you can watch on Canvas, and another one called the 3 magic cups or the disappearing water. Unfortunately, I don't have time to show you those on this video, but you can see them on Canvas if you want. And that's, again, just practicing more of what's the difference between the things you observe directly and the things you guess about them. Okay. We also watched a really good video about scientific theory. You can use this link or the link on Canvas, and it does a really good job of explaining that scientific theory is something that you, again, infer. In fact, we talked about these two terms a lot. There's a scientific law. There's scientific laws, which are statements of what is occurring. If you grab an object and you drop it, it will fall to the ground. You can observe that over and over. You don't have to have any reasoning about it. Okay, you just know that that happens. The sun rises every morning, etc. It's a statement of what is occurring. It's based on observation. And then there's scientific theory, which is a statement of why it's occurring. Okay. For example, with the sun rising one, the ancient Greeks thought there was a guy in a chariot named Apollo that was actually pulling the sun into the sky, right? One of their Greek gods. Now we have a better understanding, and we have really good reason to believe that the reason the sun rises is because of the planetary orbit of the Earth around the sun, etc., and the way that the Earth rotates. We also know for gravity that the reason stuff falls is Einstein has this really complex theory on relativity that's called that, has space bending, etc. That is the reason why the objects want to fall to the ground. But again, those are statements of why, and those can be generally revisited and made better over time as we have more and more evidence. Whereas laws generally don't change because we observe them directly. There's no reason for them to change unless we just get really good at observing something and notice something we missed before. Okay? So same thing with earth science. We have to be careful about the things that we have observed directly, which usually turn into scientific laws, versus things that we're, have good reason to believe, but they're statements of why it's occurring or how it occurred, etc. Those are scientific theories, and those can be revised as we get better and better at understanding the world and make better and better measurements. Okay? But that's pretty much it. That's all we talked about in this lesson. If you have any questions, let me know. Otherwise, thank you for watching.